Today's lesson, it's lesson 4.5 actually, is population proportion estimation. And it's also available in your MVC online learning classroom. Now, our memory verse is found in Proverbs 3 verse 7. It says, "Do not be wise in your own estimation. Fear the Lord and turn away from evil." At the end of our class today, you'll be able to identify a point estimator and also compute for the point estimate, identify the appropriate form of the confidence interval, compute for the confidence interval estimate, solve problems involving confidence interval estimation, and also to draw a conclusion about the population proportion. If you ask me, how is this lesson different from lessons 3 and 4? I must say that in lessons, wait for a while. In lessons 3 and 4, we have talked about the average or the population mean. While in this lesson, we'll be talking about the population proportion. So let's start with our venture with me. Your venture with me today is a true or false. It's available in your MVC online learning classroom. Let me continue with the chat with the expert. Now, if we say proportion, that is representing a part of a whole. Remember, proportion is synonymous to probability, percent or percentage, decimal, fraction. We still have percentile. So these are all synonymous. Now, a proportion is a fraction expression where the favorable response is in the numerator and the total number of respondents is in the denominator. For example, there are 10 people and 4 agreed that you'll go to that you'll have swimming. So we say that the proportion of those who agreed is 4 over 10, or that's 4 out of 10. In percentage, that is 40%. In decimal, that is 0.4. Now, if we say point estimate, that is a single value used to estimate or to approximate a population parameter. And if we say interval estimate, these are range of values. Here are some symbols for this lesson. If you say P, it refers to the proportion solved as P equals X over N. Example, we go back to the swimming problem. The P is 4 over 10, or that is 0.4. If we say Q, it's the estimated proportion of not P. So how do we solve for Q? That is 1 minus P. Back in our problem, that is 1 minus 0.40. Let me share my whiteboard. Remember, our P is 4 over 10, or that is 0.4. So our Q is 1 minus P, or that is 1 minus 0.4. The answer is 0.6. The next one. The next symbol is P prime. If we say P prime, that's the point estimate of the sample proportion. Remember that our P is equal to our P prime. What are other formulas or estimators for this topic? The standard deviation is also called as a standard error. That is why the smaller the standard deviation is, the smaller the error is also. That is solved by the square root of PQ over N. In the margin of error, that is the critical value times the standard deviation. Next, the upper confidence limit is the P plus, or the point estimator, you add it with the margin of error. The lower confidence limit is the P minus the margin of error. Let's have problem number 1. I'll just take one problem for point estimate and another problem also for the interval estimate. Now, problem number 1, job satisfaction. In a job satisfaction survey at a certain mall, 800 employees were asked if they were satisfied with their jobs. There were 625 who responded with a yes. What is a proportion of those who were satisfied with their jobs? And what is a proportion of those who were not satisfied with their jobs? So we represent them. We say P is a proportion of those who are satisfied, while Q is a proportion of those who are not satisfied with their jobs. The given are X, the observed value, is 625 out of N. Our total observed values is 800. So we solve for P, that is X over N, that is 78%. Then we subtract this from 1, we get Q, which is 22%. So we say that 78% of the employees were satisfied with their jobs, while 22% were not satisfied. Any questions with that? The second problem is very similar to the first problem, so I'll give you the chance to read it. Also, the third problem. These are just the same. Now let's go to the characteristics. Constant na ang 1? Yes, constant ang 1. Because remember, the formula for Q is 1 minus P. Why 1? It means 100%. So we say, example, we go here. That's 1 minus 0.086, or that's 100% minus 8.6%. That gives you 91.4%. Let's go to the characteristics of the sampling distribution. Again, number 1, the point estimate or the mean, that's here it's P hat. It can be P hat or it can be P prime, is equal to P. Next, the standard deviation is solved as the square root of PQ over N. Now, how will you know that the sample size is large? The sample is large if you will do this one, P plus and minus 3 times the standard deviation. If it does not include 0 or 1, then the sample size is large. Let me give you an example afterwards. Let's have problem number 4. A total of 200 grade 8 students who have access to internet services were asked if they play games online before attending classes. 95 students responded yes. Estimate P and Q. Solve for the mean, standard deviation, and check if the distribution is large or small. So P is for those who play online games. Q is a proportion for those who do not play online games. Our given is out of 200, that's our N, 95, that's our X, said yes. So let's solve for P. P is X over N. So 95 divided by 200 is 0.475, or that is 47.5%. Q, that's 1 minus P. The answer is 0.525, or that is 52.5%. So we say that 47.5% of the grade 8 students played online games before attending classes, while 52.5% do not play online games before attending classes. Basig after nila sa klase, magdula. Now remember, our mean is equal to P. So our mean is also 0.475. Let's solve for the standard deviation. That is P times Q. So 0.475 times 0.525 all divided by 200. Then the quotient, you find its square root. The standard deviation is 0.035. Next, let us do this one to check if it's large or if the sample size is small. So our P is 0.475 plus 3 times our standard deviation. That is 0.035. The answer is 0.58. If we subtract it, the answer is 0.37. Now, does it include 0 or 1? Is the range including 0 or 1? Remember, our range is also only from 0.37 to 0.58. Therefore, it does not include 0 and 1. And since it does not include 0 and or 1, then we say that the sample size of 200 is large. Any questions? What if it includes 0 or 1, ma'am? Then, if it includes 0 or 1, the sample size is small. Will the 30 or more or the below 30 apply here? No. Again, that's a formula to determine whether the sample size is large or small in a proportion. So here's your first activity. Let's go to the second problem. How is this different? Or how is this the same with our previous topic? The same, 4 steps. Step number 1 is the parameter of interest. What is the topic all about? Remember that if in the previous topic you only have the mean, in this topic it's about the mean proportion. Next, check the assumptions. Oops, I made an error here. You will not use this one. The n is greater than or equal to 30 and less than. There are 2 ways actually. First is basically we can use this like greater than or equal to 30 for large, or small, less than 30, that's small. But the appropriate way is the formula. Remember, what's the formula again? That is P plus and minus 3 sigma. If it includes 0 or 1, it's small. If it does not include, it's large. Now, step 2 is still ATC, assumption, test statistic, and confidence level. Our test statistic here, since it's a proportion, we call it P. By the way, it's not P test, okay? In the previous lesson, if it's large, it's Z test. If it's small, it's T test. But if it's for mean proportion, we just say P. then the level of confidence. In step 3, you'll have the given X and N. Then the point estimate is equal to proportion P. In step 4, we have the confidence coefficients. For small samples, you refer to the T table. For large samples, you refer to the Z table. So this formula here, this one can be Z or can be T. Next, for the upper confidence limits, that is our point estimate plus and minus, plus I forgot to place the minus, plus or minus the critical value times the standard deviation. Then we need to describe and interpret our results. Let's try one problem. Dr. DG discovered a new treatment that increasing the cure rate of skin diseases. He claims that it is more effective than the existing standard treatments of diseases. He stressed that out of 30 patients with skin disease, 22 were cured using his treatment. Compute a 95% confidence interval of the proportion of skin disease patients treated by the new treatment. So what's the topic all about? It's about the mean proportion of skin disease patients who were cured with the new treatment. How many patients were there? 30. So the sample size of 30 is large enough. It's a mean proportion, so our test statistic is P. And our confidence level is 95%. So our alpha will be 0.05. Out of 30, 22 were cured. So our point estimate is 0.73, or we say 73%. That should be the confidence interval. Remember, this is large. So for large samples at 95% confidence level, our confidence coefficients are plus and minus 1.96. Let me give a bonus point. How about for 99%? What's the confidence coefficient? You can unmute your microphone. The first one to answer gets
2.58, ma'am.
Very good, Abigail, 2.58. You got 3 bonus points for today. How about for 90%?
1.96.
1.96?
Yes, ma'am.
No, 90%.
Ano dito, ma'am?
90%? 1.96 is for
1.64.
1.64, very close. 90%. 1 point. Going once, going twice. The answer is 1.65, or the accurate is 1.645. That's very close, Denise. Now, let's solve for the margin of error. For the margin of error, that will be 1.96 times P, or P is 0.73, our Q is 0.27 over 30. We have a square root. That's equal to 0.16. So we subtract it from 0.73, we get 57%. And if we add it, we'll have 89%. Now, how do we state our conclusion? We say we are 95% confident, or we say with 95% confidence, we can state that the interval 57% to 89% contains the true percentage of all skin disease patients treated with a new treatment. Or here's another way to say it. We are 95% confident that the new treatment cures 57% to 89% of skin disease patients. Again, in your conclusion, be sure to state the confidence level, the parameter of interest, what else? And the interval estimate. The next problem is very similar to the previous problem. Let me check on, and here's your activity 2 for today. So for today, you'll have activities 1 and 2. That's due next meeting on Wednesday.